So, uh, very good afternoon, everyone, for joining us today for this session of Dive. And before we begin this, another exciting session on the science and perception of attention, I must tell you a few things about Dive. Dive stands for Design Thinking and Innovation. Uh, it was a forum we started, a few of us sitting at Student Labs, we thought a few years back that can we discuss design thinking and innovation in an informal setting on a weekend morning and with everyone. Idea was to make the innovation and design thinking accessible, inclusive, so that where practitioners and enthusiasts both can come and and discuss in a non-formal settings where you don't have a burden of being right all the time. While there are lots of information anyways available online on every other topic, including these ones, uh, but one doesn't know where to begin with and whom to believe, whom not to believe. So these are the questions we always encounter. Using this forum, we've tried to address some of these issues, and some very knowledgeable and amazing people have come and spoken on this platform. Uh, Idea was to make the innovation concepts more easier to digest and to apply in a real life. Today we have amongst us Dr. Tim Holmes, a neuroscientist, who is able to decode, who will decode for us some of these concepts. And by the way, he's going to tell us that even all of us, probably not just the scientists, are a bit absent-minded. We uh, we don't see what we see, and there's more to it. Dr. Holmes is a PhD in neuroscience, and he's from the University of London in 2010. And by the way, he's also a successful entrepreneur. He has formed a company, run a company, and sold it off, quite like a scientist. And the company was called Acuity Intelligence. He's worked with some of the top brands in the world, P&G, Google, Unilever, Land Rover, etc., and helping them in better user experience of physical products, digital products, retail strategies, etc. One of his engagement now, one of his latest engagement is also being a neuroscientist with Student Labs, and that's where I think the design thinking taking on some, I would say, a neuro Philip, if the term can be put like that. And it's an interesting match of two fields. Design thinking anyway buys in a lot of things from anthropology, sociology, psychology, and that's where neuroscience now comes handy with the changing equation, with the now a lot of AI playing out and our world becoming more and more complex. Personally speaking, I was coming to the content of the talk today. Personally speaking, I was blown away with the fact once Tim had mentioned in one of the presentations about human perception, that our eyes constitute only 10% of what we see, and there's a lot more happening in the back end. And while you're watching me speak right now on the screen, there's a lot of back end processes that are happening in our head to perceive or to process this information. And this back end process is something which requires decoding. To our advantage, we can do that. And that's where designers, business strategists, retail strategists, or even a public administrator would benefit from what is going to unfold today in this little over one and a half hour. With a small intro, I would like to hand over the stage to Tim. And Tim has a presentation material for around 45 minutes with a short recap and interaction in between. And later, the floor will be open for audience to put questions, which you can put in your chat window. In fact, audience can keep typing the questions in the chat window as and when they occur, and we'll pick it up in the interval time, or maybe you can say recap time, or towards the end. And the questions would be probably around 40 to 45 minutes, 30 to 40 minutes. And of course, these questions will be picked up by my colleague Sajid, who is managing this session today in the backend, and I can read it to Tim. That's how the things are managed online, and this would work this way. So with this little intro, on dive, on design thinking, on Tim's background and the content today. Tim, the stage is yours. Thank you for joining us today, and very excited to hear you again today.
Okay, thanks, Manoj. Let me just get my screen up for you. And because there's a lot of research that suggests you only trust people that you can actually see, I should probably stick my camera on there as well. Right, okay, so now you can see me while I talk. So thanks for inviting me to be part of this dive session today, and a big thanks particularly to everybody who's given up part of their Saturday to be here. I know that's not always easy, and I'll do my best to try and make this fun for you. Before I start this morning, what I want to do is just explain this rather cryptic title, because you're probably thinking, seeing fast and slow, I just see, right? Well, it's a riff on the title of Daniel Kahneman's book, Thinking Fast and Slow, which I happen to have a copy of right here, which summarizes research that he did with Amos Tversky and others on how the brain makes decisions. It's become something of an industry standard and certainly was a bestseller. And it's helped to give rise to a field that we call behavioral economics, and in particular to something called nudge theory, which has been behind many of the biggest behavior change initiatives in public health, personal finance, and lots more. So don't worry if you haven't read it, because I'm going to actually fast track the main idea from it for you in just a minute, but there's still time to put it on your Christmas list if you're interested. So I'm going to just introduce myself a little bit. You already heard from Manoj sort of what my background is. So, a mathematician turned psychologist turned neuroscientist, and as he's said, that I've been after forming a company, Acuity Intelligence, worked with some of the world's biggest brands, conducting research and developing education programs for them. And one thing has never failed to surprise me, and that is how much people take for granted about vision. It's especially true for designers and for business strategists and brand managers and so on. So whilst we're not going to have time today to go in super deep on the vision science, what I want to do right now is to encourage you to think a little bit about your own experiences of the world, how reliable you think they are, and most importantly, how much you assume that everyone else shares your conscious visual experience. Because as you will see today, even if you can get a customer's attention in the right place, they won't necessarily see what you're showing them. Now, as a vision scientist, I like to include plenty of demos so that you can experience some of the principles that I'm going to be talking about for yourself. But I should warn you in advance, these demos have been created with a sort of laptop-sized screen in mind. So if you're tuned in on a handheld device, you might want to maximize and go to landscape mode to view some of the demos. And if they don't work for you today, then I'd encourage you to go back and check out YouTube when the whole stream's available again to rewatch in a couple of days' time. Now, to illustrate what I mean about this screen size issue, I thought I'd start the way every self-respecting vision scientist does, with a visual illusion. And if you're looking at this image on a laptop and it's within about 60 centimeters of you, then the chances are that you think you're looking at an image of Albert Einstein. Now, if you're sitting further away, if you don't have the screen maximized, or you're looking at this on a mobile device, you might be seeing someone else, or it might just look like a combination of faces. If you want to see Einstein, try reducing the distance between you and the image. So bring the phone close to your face, or actually lean into your screen a little bit. What I'm going to show you is what people who were looking at this on small devices would have seen. If I shrink the image, you'll start to see another face appearing. And as I make it smaller, the more recognizable Marilyn Monroe should become in this image. Now, I'm showing you this to emphasize the point I made about screen sizes when it comes to vision. The size and distance of an object from the viewer changes everything. And it's something that's often overlooked, especially by digital designers. Here, the two images are embedded in the picture, but their spatial frequency, and by that I mean the resolution of the fine detail within those two images, is different. The low frequency Einstein image becomes increasingly blurry at a distance, allowing the high frequency Marilyn picture to be perceived. That's a neat trick, and I'm always surprised that I haven't seen it used more in signage and billboards and packaging. It's a great way to create engagement as people get closer to something, is to change the image. By the way, the amount of time that you actually see this image for can affect how you perceive it. If I were just to flash the screen very briefly, the image very briefly on screen for 30 milliseconds or so, you'd all perceive Einstein regardless of the size. And if I were to show it for longer, then at the smaller sizes, you would perceive Marilyn. Which brings us to the subject of this webinar, which is about using vision science and some of the really fast processes to improve customer experiences. Now, before I go back to Daniel Kahneman's book, I want to try something with you first. Cast your mind back to a time long before COVID when there were these things called dates. People used to go out and they used to meet people and have drinks and be sociable. Well, I want you to imagine that you've just been on a blind date and you really like the person that you met. So much so, you arrange to meet up with them again next week. And then you get a message from them. I'm going to show you two versions of that message. I want you to notice which one makes you feel less certain about that next date. Is it this one? Or is it this one? I'm guessing that for most of you, it's that second one. Now, it's the exact same message, right? It's just in a different font. And I like this example because it illustrates how a simple design decision can dramatically alter your emotional response. The ink splodge, probably, by the way, you're starting to think now might be blood because of the font. And that's how these associations can be triggered in your brain. It's in fact an example of an automatic response to an image, and almost certainly would trigger a decision to cancel the next date. Now, in his book, Thinking Fast and Slow, Daniel Kahneman describes two systems for making decisions. System one is what you've just experienced, and is in fact how the majority of your decisions are actually made. The decision making is unconscious and probably doesn't even feel like a decision to you. In fact, you make upward of around 10,000 decisions each day, and 95% of them are like that one. As you saw with the two notes, the decision feels automatic because the brain isn't really stopping to evaluate all the possible outcomes, which makes it super fast. It's seen enough TV shows to know that the second font is bad news, right? And this kind of decision making is using what we call heuristics or probabilities to go with the best decision it can as quickly as possible, which means it's quite likely to be irrational. After all, you might have spent the first date talking about your mutual love of horror movies, and that second note was just an ill-fated attempt at humor. So what about the other 5%? Well, system two is the decision making that you will recognize because you are conscious of it. This is the decision making that occurs when you're learning something new or are confronted with something that doesn't make sense. Those of you who have learned to drive a manual car with a stick shift will remember how slow you were at changing gears when you started learning to drive and how automatic that becomes over time. That speed change is the decisions moving from system two to system one. Now, system two is slow because it tries to evaluate all possible outcomes, and this rationality isn't fast. It's so slow, in fact, that you simply couldn't function if all your decisions were made that way. And what you end up with is a first past the post process, which I'm going to illustrate for you now using a rocket to symbolize the fast system one and a little old plane to symbolize the slightly more sluggish system two. When the heuristics hold true, the outcome of two systems will be the same, but system one will always get there faster. When the heuristics are mostly true, system one will arrive at an okay decision before system two can arrive at the optimal decision. And so you'll actually probably go with the okay decision rather than the best decision. And of course, if the heuristics really don't apply in the current situation, then system 1 will end up making a fast, wrong decision with inevitably unfortunate consequences. And it turns out that the visual system uses heuristics in the same way. You would be overwhelmed by all of the visual information your brain receives if the conscious experience wasn't filtered somehow. And we call this filter attention. Now, attention is really helpful in maintaining relevance to your conscious experience, but it's also quite fallible because it can filter out important things based on assumptions. And for many of you, you may not have noticed that the title of the book on the right has now changed. The author's changed, and the prize has become something slightly less significant than the Nobel Prize. This is because attention works like a spotlight, filtering out what it believes it has already seen or what is irrelevant. That image of the book hadn't changed over several slides, and so your brain had started to assume that it was never going to change. Moreover, we were talking about system 1, and so your spotlight was focused on the rocket. Let me just replay that slide, and this time I'm going to show you the spotlight. That spotlight will move with the rocket, which is what you were doing last time. But what I want you to do this time is follow the red arrow when you see it. And you'll notice that I waited till the explosion to make that change on the book title. Because if you weren't already looking at the rocket, I wanted to make sure your attention was over on the left-hand side. Now, it turns out that the visual system has a sort of spotlight hardwired into it. And this is because of the distribution of photoreceptors, the rods and cones that you learnt about in school in biology, on the retina at the back of the eye. Now, they aren't uniformly distributed, and in fact, the cones in particular, which are responsible for color vision, are highly concentrated within a fairly small region of your visual field. The most concentrated region is something we call the fovea, and it occupies about 2 degrees of your vision. What does all that mean? Well, it's about the size of your thumbnail if you hold out your arm to maximum stretch. I visualized it here for you on this image of my Pixel 4 XL, if you want a scale kind of sense of it. That's how big it is. Now, your color vision doesn't just disappear outside of the fovea, but it does degrade rapidly. And by the time you hit the edge of what we call the paraphobia, shown here, your vision is mostly monochromatic. It's also very low resolution and is more about detecting changes in the scene than processing the fine detail. Now, I don't want you to get bogged down with terminology like fovea and paraphobia, so I'm not going to use lots of that terminology today. The important thing to note, to remember here, is that this limitation on your vision is happening all the time. And the illusion that you have of seeing the world in full color and full focus is exactly that. It's an illusion created by the brain. Now, the fact that you can only actually see this small part of the visual scene in detail is the reason that you move your eyes to look at things and to interact with things and to read things. And when you move your eyes, you're moving that spotlight. And what's outside the spotlight, for the most part, might as well not exist. And if you don't believe me, next time you get a chance to look at your device, or if you're looking at one right now, just look at the top corner of your screen and try keeping your eyes stable, but trying to look at the rest of the things on the screen. And what you'll find is you can't recognize or read much far away from where you're keeping your eyes. In fact, you certainly won't be able to read anything at the bottom of your screen, even though it might feel like your screen is in full focus. And so this is the reason why when we want to study things like attention to design, we use technologies like, or we can use technologies like eye tracking, because they can be super informative. Which brings me to this chap. Happy smiling Russian. If you think of eye tracking as being relatively new technology, then think again. This is Alfred Yarbus, and he was playing around with this rather scary looking equipment back in the 1960s. And even he wasn't the first to use eye tracking, but he was certainly one of the most influential. Now, I don't want to put you off your lunch if you're in India. I don't want to put you off your breakfast if you're in Europe, in the UK, or off your supper if you're on the West Coast. Depending whether where you are, whichever meal it is. But he used these contact lenses, which were glued to the subject's eyes and had a little mirror sticking out from them, onto which he shone a bright light. He traced that pattern of reflected light onto images as the participants moved their eyes. And after completing this study, the lenses were removed, and it took a few hours for the participants to get their vision back to normal. It was painful. Now, funnily enough, with Yarbus, we're not talking about large sample sizes. It's not one I'd have volunteered for. But the principles he was using are the same ones that we use today, but altogether with much nicer looking equipment like this. On the left, you can see a Tobii Nano eye tracker, which is a very tiny eye tracker that you can clip onto a laptop, and you can eye track people looking at the screen. On the right, you can see Pupil Labs' invisible glasses, which allow for completely portable eye tracking. So you can eye track people when they're driving, when they're walking around a store, and all sorts. Both are non-invasive. They're easy to use, and they use infrared light rather than white light, as Yarbus did. And they also leverage the natural reflectivity of the eye, which means that they don't interfere with the user's vision at all, and they're completely non-invasive. But back to Yarbus. He did something unusual for eye tracking studies, at the time at least. Instead of showing one image to lots of people and looking where they looked, or showing lots of images to one person to see the difference in where they looked, he showed the same image to the same person lots of times, probably because he couldn't recruit that many. But each time he asked them a different question about the image. This picture here is called The Unexpected Visitor by Ilya Repin. And here you can see a trace of the eye movements when the subject was asked to remember the positions of the people and the objects in the room. Notice how it's ignoring all of the empty space in the room. It's actually missing that picture in the top right-hand corner on the wall, and not so good on maybe on some of the faces over there. But it's sticking with where all the people and the objects are. Here's another trace from the same participant. This time, they were asked to remember the clothes that were worn by the people in the picture, and you can see just how different the path is. Here are some of the other traces, and these are the two that I showed you. So what does this tell us? Well, it shows that attentional spotlight, as represented by the eye movements, is focused on what is of interest to the viewer at any moment in time. In other words, attention acts like a spotlight that's moved by the viewer. And it's affected by the viewer's expectations. For example, in response to the question, what are the ages of the people in the picture, you can see in this image how the attention was focused on the faces of the people, because that's the most likely source of information about their age. Now, this type of spotlight represents our conscious experience of attention. It feels like we're in control. We're moving that spotlight, right? But is that always true? Time for you guys to try something. And this is one of those times when you will need to have your screen maximized if you want to see this effect. Hopefully this will work for some of you. If not, then I apologize. On a decent sized screen, it will work. What I'm going to do is I'm going to show you a cross. Whenever you see crosses come up on the screen, I want you to look at the cross. It's a vision science thing. We do it all the time. And on a few occasions, I'm going to show you some screens where I'm going to ask you to remember or write down, if you can, the first number that you see. So let's just show you this little lady. And what I'm going to do now is ask you to write down the first number that you see on the next screen. Didn't have long, did you? Everyone got a number, I hope. So let's go again. This time I'm going to ask you to write down the number that you see on this screen. And one more time, the first number that you see on this screen. Now, if I did my job right, the numbers that you have should make up a very important date in history, one that will go down in history. And that's this one. It's today's date. It's the date of my webinar. Of course, that didn't happen by accident. That happened because in each case, I used a different technique to influence your attention. Now, these were just some of the reliable ways that attention can be manipulated. And what they tell us is that we now need to go back and refine that statement about attention. Because in fact, the attentional spotlight is actually moved slowly by the viewer, but it can be moved very quickly by an involuntarily by the stimulus itself. In other words, attention can be disrupted by design. Now, unfortunately, I don't have time to go into detail on all three techniques that I used there. Feel free to hit me up on Twitter or LinkedIn if you want explanations of them. But here's a commercial example of one of them. This was a study by Think Eye Tracking, and in this study, 200 participants were eye-tracked looking at a shampoo ad. On the right, you can see what we call a heat map, and the heat map shows the distribution of attention. The redder the heat map, the more attention was allocated there by the participants. And you can see that the model's face is getting plenty of attention, and that's a well-known effect. But it's not the model that the brand wants you to remember when you're out shopping. It's the product. So a few minutes in Photoshop later, you get a very different result. This time, all the viewers are looking at the product, and it's almost all the viewers. And it's simply because we reflexively follow the gaze of somebody that we're looking at. And this is because one of the processes, the automatic processes that the brain has learned is that, well, what's of interest to somebody else might actually be important to me. If I want to understand that person, I need to understand what they're looking at and interested in. So now we've seen that we've got methods that can get attention to the right place, and they can get attention to the right place quickly. So job done, I can finish my webinar, right? Well, not exactly, because just because someone looks at something, it doesn't mean that they really see it. Take a look at this. If I ask you which of these three cacti looks largest to you, I'm hoping that you will say it's the one on the right, Tim. It's the one that's looks furthest away. But of course, if I remove the background, you'll see quite clearly that they're all the same size. The funny thing is, as soon as I bring that background back, the illusion returns. And this is because the brain also has a whole load of these heuristics that drive what we call visual perception. Now, perception is the conscious visual experience that results from an interaction between the image and the viewer's expectations, their hopes, their past experiences. Everything about the individual viewer can affect perception. And in fact, the image that they're looking at only contributes about 10% of what you perceive. The other 90% comes, the red area of this pie chart, comes from those expectations, making a really good case for getting to know your customers. Because if you don't know what motivates them, if you don't know what they expect about your products or your type of product or your website, then it's very hard to make very strong predictions about how they're going to perceive your product or your website. In this case, the depth cues in the image are suggesting that the rightmost cactus is further away, which means that it actually should look smaller because things that are further away look smaller, right? For it to look the same size as the cactus which is closest to us, it would have to be bigger. And so the brain perceives it as bigger. And that's why you get the illusion. Now, this is, of course, a system one type of error. The heuristics here that are being used only actually apply in three-dimensional real-world space. But they are so automatic that they still get applied when you're looking at a 2D representation of a 3D space. So this is an example of the rocket going to the wrong decision, but this time it's your brain that's exploding. Now, every vision scientist is part magician, and I could easily fill the rest of our time with lots more examples of how your perception can be fooled. For example, you'd probably tell me that you're seeing different colored circles here, but you're not. You might tell me that you can't see 16 circles here, but they are there. And you definitely tell me that the top tile here looks darker than the bottom one, even though they're exactly the same shade of gray. I don't have time to explain why all these work. If you want to send me your ideas, I'd be very interested to hear them, and I'll let you know whether I think you've got them right. But I want to show you an example of how messing with perception can actually create engagement. This is an example from, I think it's the World Wildlife Fund, who applied some serious vision science to tell a very compelling story. It's a similar example to what we saw with the Einstein image that you saw at the start. Now, if you're looking at this on a big screen, it's probably doing a number on your eyes and you can see lots of wavy lines. If you're looking at it on a small screen, the two images probably both look like what I'm going to show you in a minute. The bigger the image, the harder it is to see the panda in that image. And that's because what you focus on when you see the big image are the zigzag lines. And the changes in the thickness of those lines is very subtle. If you try actually looking at that bigger image out of the corner of your eye, you should also see this effect, by the way. You should be able to see the panda. Corner of your eye, I mean peripheral vision. So actually look over to the right-hand side of the screen and then sort of try and shift your attention to the left. You can see the panda then, and that's because the resolution of peripheral vision is so poor that you can't actually see the zigzag lines. You can't break out the zigzags. What you actually see are just patches of light and dark, and that's what makes up the panda. So it tells a nice story about a vanishing population. So perception is the interaction between the viewer's eyes and the viewer's brain. 90% from the brain, remember. And just like attention, perception is also affected by the viewer's expectations. It's also affected by how well their visual system works. And we haven't really talked much about sensation, which is a whole separate topic. It can be disrupted by design. We've just seen examples of how it can be disrupted by design using illusions. Sometimes it can be unintentionally disrupted by bad design, and that's definitely a whole nother webinar. And that's the kind of thing I spend a lot of time talking to clients about. More importantly, it can be facilitated by good design in ways that will really benefit your customer. And so before we go on now, let's just take a couple of moments to capture what we've learned. When it comes to design, it doesn't matter whether you're in advertising, whether you're in web design, or whether you're in product design. If the customer's perceptions aren't managed, then you're potentially wasting all your effort on those designs because they might not perceive it the way that you perceive it, the way you intend it to be perceived. And if the customer's attention isn't managed, then you're losing control of the story. Because if they're not looking in the right place at the right time and seeing things in the right sequence, then your designs might as well not exist. And because these are fast, unconscious processes at play, it also means that if you ever stop to ask your customers to explain, well, why didn't you see it? Or I don't understand why you misinterpreted this, can you tell me? Then they're not actually going to be able to explain it because they are almost certainly unaware of it. And this means that a lot of the traditional self-report methods that we use when testing design won't cut it. And this is why behavioral research and neuroscience methods like eye tracking, arousal measures like galvanic skin response, brain activity measures from EEG and MRI, or other implicit testing measures can offer the potential to understand the real root cause of a visual design problem. Now, before we go on, I'm going to take this as an opportunity to stop and take some questions because we're at the end of sort of like the theoretical part of this. We're going to go into a bit more applied stuff in a moment. So, Manoj, do we have any questions?
Yeah, Tim, let me just check what's coming from the stream. Well, people are still soaking in, I guess. Well, I have one question for you while people can think through their questions and something may come up. So when we think of usual market research, the conventional market research where we go to the consumer or customer and put across a concept, a visual concept at times, a logo or a product aesthetic prototype or something like that. We can show concept number 1, 2, 3, or at times we may go micro or ask for their opinion on a logo or a specific visual. So how does this entire jugglery of system 1 and system 2 work through that? Now that we know people respond through essentially through system 1, which is their irrational perception or irrational, you can say, decision making, which is taking shape. Or on the other side, we talk of biases, which is probably you might be referring to. You can correct me if I'm wrong. In the system 2 part. So how does it really work out from when you look at it as a neuroscientist, as a vision scientist, the entire process of going through the conventional market research of showing 3 concepts to a consumer?
Okay, it's a really good question. So the biases mostly play out on system 1, but they play out so quickly that the person that you're testing these designs on won't be aware of it. So first of all, I would say that asking for someone's opinion about a design is always a valid question, because what you're getting there is sort of the slower response. The thing that's typically missing when you ask that question is what we call the implicit or the instinctive response when they first see the image. And there's various ways that you can actually probe this. Examples that we use a lot in vision science is we don't give people very long to look at an image. So we'll flash an image for half a second. Turns out actually a second is long enough for people to form a really good impression of any visual stimulus that you show them. If you give a very quick flash of an image, then or a logo, then you can understand better what the implicit response is going to be, what the automatic response is. As soon as someone takes some time to explain it, however, the system 2 is still playing out, and you've got time to get this sort of more rational, more post hoc explanation. And just because somebody has felt something, then they will start to try and explain it, and they'll start to try and explain why this is reminding them of maybe you flash a Coca-Cola logo and they're reminded of drinking a nice cold Coke on holiday on a beach or something like that, and so they're talking about all these associations that come with a brand logo. Then all of that is a much slower process that's playing out, and it doesn't necessarily speak to things like recognition of the logo. It doesn't necessarily tell you how the logo is going to perform in context. We're going to see some sort of eye tracking examples in the second part, and one of the things about your eye movements, you typically move them in a series of what we call fixations, and these fixations are typically 250 milliseconds plus. So we're looking at sort of 3 to 4 of these fixations per second, and those are basically the snapshots that your entire visual experience is built from. And so we're not talking necessarily about super long exposure times whenever you look at anything, because your eyes are constantly moving around, you're constantly looking around. And if you think about people when they're looking at something like a supermarket shelf, they're scanning, trying to find it. Most people don't want to be in a supermarket for that long. I can't stand it these days because of wearing a mask. I just want to get the heck out of there. But it's this rapid searching is also related to the fact that people just want to get on with their lives. So understanding the context of the behavior and also the context that the design is going to appear in are important things, and that's what's going to change that implicit response. And so I think this is where the self-report can be very useful for understanding, well, what's the sort of the takeaway? What do you take away from this after you've known the brand for a little while, maybe? But the instant response, the one that might trigger a decision, and we're going to see an example where it can trigger a completely wrong decision in a store environment in a minute, then then you need to be testing with much shorter exposures, and there's also some great research on the internet that shows people actually drawing pictures of logos that they've seen, and you'll get to see just how little of a logo is actually encoded in memory in the first place. It's not the whole thing typically. It may be the color, it may be a couple of features, but not the whole thing.
Well, so well, I have more queries on that, but I guess now there's a stream of questions for you, and I don't know whether this will be a micro break or a longer break. However, there are two questions which point to the same thing, or same question is being asked in two different ways, and I think it's very relevant here. Which is, now it's touching the ethical boundaries. How can we decide whether we are manipulating or influencing? That's question number one. Which is connected one is, where do corporations and enterprises draw a line to measure and map data? Academics do it with a different goal, but how can ethics be introduced to the corporation with this regard? So people, now that you're talking of system 2, and it can be influenced using design, where is the line of being there? So maybe you can take this up, and then I have several.
Okay, so I mean, the ethics is a really big question. We could spend the rest of the time talking about that, I think. First of all, influence and manipulation, I actually think they're the same thing. I think it just depends on which side of the coin you're looking at it from. If you're the one that's trying to get attention to a particular case, you might want to call it, sugarcoat it as influence, but you are manipulating attention. If you're using it for more sinister means, then I guess we would call it manipulation of attention. Bottom line is, you can influence attention quite rapidly, and these are processes that will work for almost everyone. I don't take chances when I do a webinar. So these were things that I was showing you that work for the majority of the population nearly all of the time. And so they're very reliable effects, and you'll see them being used all the time. The whole idea of pop-up ads on the web is coming from this attempt to influence attention, and we know how annoying those can be. And we also know that over time, the brain can start to learn to suppress attention to those. The reason why people don't look at a lot of ads online is because the brain knows where the ads are going to appear now, and so it's starting to suppress attention to those locations. So the brain adapts, the brain will adapt. But I really don't actually, I genuinely don't think there's a difference. The ethics of it, I think, become a whole different question, because if you're trying to manipulate attention or perception in a way that is trying to sell fake news, for example, if you're trying to do something in a way that that is not true, not honest, not helpful to the user, not is what the user actually sort of would want to achieve, then potentially you're straying into a darker ethics question. So did you want to talk about the methods as well? Because I think one of the big questions, and one of the scary things for a lot of people, is that they often think of these tools like eye tracking and MRI and so on as being sort of mind reading tools, that they're ways of getting inside a person's head. And at the moment, we're certainly not in the mind reading place. Well, where we are, we're in a sort of just an understanding place. And so when we use this for research, clearly, people are always aware of the fact that we're using it. Now, when I use eye tracking, people always have to sign a declaration to say that they know that they're using eye tracking, and I always explain the technology to them before we actually run the study. And for this reason, sometimes people can get a little bit nervous for the first few minutes when you do an eye tracking study, and you can actually see that their eye movements are slightly different, their behavior might be slightly different, so you kind of need to allow a bit of time for their behavior to settle down again. But I think the really worrying part is that technologies like webcams, for example, can be switched on remotely and can be used to do some form of eye tracking, for example. They can be used to sense temperature changes through people's skin color and so on. So you can start to see some methods by which, just using the technology that people already have in their homes without any special new technology, these methods to look at what's actually going on in terms of an involuntary response can be used. And I think there's just a massive massive problem, because it's invasive, right? And consent is not given. Consent on how to use that data is also not given, and that's the other important part here. Just because somebody gives you consent to record their eye movements, they don't necessarily want to give you consent to do everything you'd want to do with the information that you learn from those. And so whenever we do academic research studies, and when I do commercial studies, we always explain who the data will be shared with, what data will be shared, and so on, because you have to. In Europe now we have GDPR, and it's really important that well, we have it till the 31st maybe, that people understand how you're going to use the data. We only have to look at the likes of Facebook and so on to understand that people freely can give data and then start to get a little bit worried about how it's being used later. And so trying to explain that up front is an important part of handling this ethical question.
All right. Okay, so there is, I'll read it to two more questions, and they are both pointing to some natural boundaries of our existence, versus how neuroscience is playing it out. One is saying, neuroscience perspective, how much of decision making is dependent on vision, because we have other senses as well, touch, smell, hearing. So how does the decision making play out on the other senses bit? Or as a neuroscientist, you would rather stick to the one sense on a heavier side. Well, I know from our other reading that our sense of smell is much stronger than any other sense, but maybe you can have your take on this. And the connected question is there a neurological basis for why we associate certain material, textures, colors, or shapes with certain emotional attributes? Is it all created by nature, or even that can be manipulated?
Oh, okay.
So both our sense and perception as we are given versus what can be probably influenced, not manipulated, if not manipulated.
Right.
And do other senses play a part, or how much they play a part?
Let me deal with the other senses part first, because the senses operate at different speeds, and as you rightly point out, vision is just one of the senses. It turns out in the brain, vision is the most important sense, as in it gets more actual sensory cortex allocated to it than all of the other senses put together. You know, if you're a sighted individual, you'll know from your own personal experience just how important vision is in your day-to-day function. It's what makes my work so broadly applicable, is the fact that we use vision as part of the decision making all the time. That's not to say it's the only sense that we use, but it is probably dominant. And one of the things that shows this is I did a talk a couple of years ago, and it's really interesting looking at the interactions between the sensory modalities. So as soon as you start to have sound and vision playing together, you'll find that the audio can actually interfere with the visual perception, but vision can interfere with the audio perception as well. Vision is the signal that's so strong that it will actually cause an audio signal to change in your perception. The same with taste. The same with touch. So vision can change everything, whereas some of the other senses don't necessarily change your visual perception. So vision tends to dominate in decision making. Obviously, for sighted individuals, it's a whole different question if sight is impaired somehow. The second question then about sort of associations with textures and colors and so on, emotional associations. Emotional associations are clearly really important, because that example that we saw at the very start with those two notes is an emotional response that's being generated based on a design cue, and emotional responses are the ones that we typically associate with these rapid decisions, these things from system one. Now, what I would say is the example that I showed you was one that had been learned, right? It's one that had been trained over time through exposure to cheesy TV programs and horror movies and all that with scary fonts and all of that. Red is being used there deliberately because red is the color that's associated with sort of love and romance and all of that and passion, but also it's the color of blood, right? So that red is working particularly effectively in that demonstration. But there are potentially there's certainly some theories to suggest that there is some sort of ecological aspect to how we emotionally respond to things like color. So Steve Palmer has a theory called his ecological view on color, which talks about how people's preferences for color sort of evolved. So, for example, if you generally ask people on a color preference, then the majority of people are going to go into the blues for their favorite color. And he suggests that this comes from things like blue sky, blue sea, from exposure to things which have given us sort of positive experiences. Whereas if you ask them a least favorite color, it's probably going to be in the sort of greeny, browny, yellow, sort of murky space where things start to look like decaying food, mold, like other things that I'm not going to talk about right now. So these are things that we've learned that we know not to like, that we know to avoid because they're bad for us. We've got negative associations with these. And so these kind of processes are explained by this ecological valence theory. So some are hardwired or sort of hardwired. Some are going to be learnt over time. And I think the mission of any designer, the mission of any brand is obviously to create that learning. Is actually that what they're trying to do is sort of to create a response, a strong emotional response, preferably I would assume a good emotional response to a design. And so what they can do is they can leverage some of the stuff that's already been learned or from other designs, from other brands, from other experiences, but then apply those in an innovative way. Or they can start from absolute scratch and train something up new, but that's going to take a while normally.
So in a way, designers should be sort of heading for the better design for system one, in a way to attract the responses from the system one and not affect the system two, unless we deliberately want to take them to a different point of view of different behavior change or
right. So I'm gonna come back to that a little bit in the second part, because sometimes you don't want things to be fast. Sometimes when you're talking about something which is more complex, something that is more rational. For example, if you were to do something like you were designing a document that people were signing in hospitals about do not resuscitation orders and things like that, that's not a small decision. That's a decision you want to take rationally, and so you don't want people you don't sort of want to have a nice big red do not resuscitate and a small gray resuscitate on that page, so people's attention gets drawn to one thing and they just tick it. That's not how you want this to work. So sometimes you actually want to slow attention down. Sometimes you want to make attention sticky, which means that it sort of linger. You want to create engagement. And we see advertisers doing this all the time. There's all kinds of examples of things like those visual illusions where something is created, is put into an ad that actually causes you to go, huh. And the huh moment is actually the bit that the advertisers want, but they had to create engagement to do that. They had to get attention to slow down long enough for you to realize that there was a joke there at all. And so there are different times you want to apply different methods. So it's not all about fast. It's about fast and slow, and using it in a way that works for what you're trying to achieve.
All right. I guess interval is becoming rather too long, and it's time to move on. And I'll keep the questions for the later part. And you may please proceed for the
Okay.
next.
Okay. Cool. Well, we can get back to the questions pretty quickly. This bit's not is a little bit shorter.
There's a
So
quite long list following anyway. So
okay, awesome. All right. So I'm going to take you back to something from the first half. What I'm going to do in the second half is try and make some of these ideas a little less abstract for you, but I'm going to start with balloons because, hey, it's nearly Christmas, right? Balloons are fun. When I showed you this image earlier, the reason that you saw the 20, hopefully, before the O2 is that the red is standing out more than that dark green. The black on the red is also standing out better than the black on the dark green does too. Now, if I'd shown you the original version of this image, which is this, then where your attention shifted becomes much harder for me to predict. And as I say, I don't like to take chances in demos. I want to be able to see the effect. So I didn't show you this image. I showed you that other one. But what I want to show you now is the eye movements that probably happened when you were doing that, when you were looking at that image. So this is an example of eye movements of a viewer looking at that picture of balloons that I showed you. It goes very quickly. It's going to be in the top left-hand corner. Watch the yellow circles. Okay, that's it. Goes very fast. Those circles are representing those fixations that I mentioned during the discussion in the break. And fixations are the time when you are cognitively processing the image. During the times when you move your eyes, you're mostly blind by the fact, but in fact, your vision is suppressed. You're not consciously aware of that. If you don't believe me, after the webinar, go to the bathroom and look in the mirror. Don't try it on your phone. Look in the mirror. Try seeing if you can move your eyes. You will not be able to do it because your vision is being suppressed. So that's another illusion that your brain is creating for you as we go along. But did you see how quickly in that video the attention shifted to the balloon? Let me just play the video again because I say it did go very quickly, and I'll just run this one for you one more time. So boom. Those larger yellow circles are engagement level fixations as opposed to just reflexive fixations that you can see from in the smaller circles. So now have a look at what would have happened if I'd shown you the full color image. And you can see now that it takes a lot longer for things to get down to that red circle. In fact, it takes a whole 2 seconds longer for attention to get to that circle. Now, 2 seconds might not seem like a long time, but in vision science and in decision making in the brain, 2 seconds is the difference between it ever getting looked at or not getting looked at all. So attention mechanisms are automatically drawn towards regions of a scene which stand out from the rest of the scene. Now, we call this visual salience. Again, don't worry about the terminology, but it's so reliable that actually we've got algorithms that can predict how these things work. This is a system 1 type activity, and it occurs because the brain has learned that regions that stand out from the scene are typically the best sources for information to understand the scene. So it goes to those conspicuous locations first. Of course, it also works in reverse. Here's a picture of me at almost every party that I go to, because believe it or not, I'm actually pretty shy, and all evidence to the contrary. I don't like attention. Well, I love attention, but not when it's actually turned on me. Camouflage evolved as a survival technique because of this automaticity towards things which stand out, this automaticity in attention towards things that stand out. So if you don't want attention, then don't stand out. Simple as that. And it doesn't just work for frogs like this or Tim at parties. A few years ago, I did a study for the British Brand Group looking at how own label products, which look kind of like branded products, can be mistaken for those more expensive branded products by shoppers. Now, other research at the time has suggested that around 20% of shoppers in the UK reported at some point having mistakenly bought one of these own label copycat versions, which of course meant that the brands would be losing out business. Now, in this study, which you can download the full white paper on if you're interested in, from the British Brand Group website, I heartily encourage you to go read it. It's a very interesting study. I know because I wrote it. We showed participants full-size supermarket shelves. You can see an example at the bottom of the screen. And we asked participants to look for the branded products. They didn't know the copycats were there. Whenever both the brand and the copycat were present on the shelf, participants always reported having found the brand. It was there, so their report seemed true, right? But we were eye tracking them when they were looking at the brand. And we discovered that sure enough, 20% of the time, they were actually looking at the copycat when they declared having found the brand. So they're staring at one product and telling me that they've seen that they're actually looking at another one. Now, this is system one in full effect, because the own label products are similar enough that they are as likely to attract attention in a visual search as the brands. But they're so similar that they make the brain perceive the branded product, which is what the user's expecting. And then that can trigger a purchase decision before all the visual information has been processed. System two taking its time to catch up. Now, this is an example of something we call the availability heuristic, and it shows how confusion can be created for customers and for users, and you see this online all the time, when things which are actually different look too similar. And whilst it suggests that brands clearly have to work harder at attracting attention in this environment, they also need to distance themselves visually from the camouflage copycats, which is actually a lot harder to do because it might require them to have a complete rethink of how they use the visual assets in a way that makes them less easy to mimic, less easy for someone else to copy. So it's not just about attracting attention, because sometimes we actually do, as I said in the break, we actually want to slow attention down. Sometimes we want to slow it down just to allow time for perception to catch up and to allow rational decision-making to play out. Sometimes we want to guide attention. So we're not necessarily wanting to make somebody look at one thing in particular. We want to send it on a complete journey, a multi-stage journey, and leverage the benefits that would come from sequencing the information that people encounter along that journey. And we can do that. Sometimes we want to train or retrain attention so that existing fast processes can either be broken or facilitated. Remember, system two is what you use when you're learning. So you have to go through system two to get something happening quickly in system one. So if you're training a behavior, or if and eye tracking, for example, is used a lot in training techniques, you can actually use the eye tracking to help to guide attention to a particular location so that people learn to do that implicitly and it becomes a system one behavior. Important thing is once you understand the behavior, you can design a nudge and then you can test the behavior again. So let's have a look at a perception example. Now it's easy enough on the web to find designs for pages that scream out for a little vision science, like this one. This one actually screams out for a little science, but you don't have to stray quite so far from the mainstream. Craigslist is an example of a site that slams the brakes on almost all of those fast visual processes because it's just text. Text is typically slower to process than images. So any text-heavy site like this is going to slow the user down. They've avoided the use of images or iconography that would help the user to narrow down their search so the user doesn't even know where to start on something like that. The headings are their only cues, really, and you've got to read those headings, and reading takes time. Reading takes time, by the way, because, as we've seen, you have to move your eyes. You have to get that phobia on the words, and they take time to do it. So it's a physical action in the body, and like reaching and typing and everything like that these things are slower than the way the brain actually works through neuronal transfer. And so you're actually slowing the user down when you have to invoke eye movements. So I encourage people to try and minimize that a little bit on their websites. The multiple column format here is also actually messing with another system one behavior, which is reading strategy, because actually it's breaking the normal conventions of top to bottom, left to right, because you've got to return within smaller areas of the screen, and they're not even very clearly delineated even. In short, it overwhelms the user, and in fact is the website equivalent of this. But of course, with Where's Wally, they're applying vision science deliberately to make things hard for the user because it's fun, whereas Craigslist, I suspect, are not. Now, similar mistakes are commonly used on, or commonly seen on, other sites. So I want to show you a couple of commercial sites. So this is actually the website for the insurance company that I use. I hope my premiums don't go up as a result of saying this, but they've forsaken the use of icons or images to force the reader here to read each of the insurance types to find what they're looking for. So particularly a new user's got to read everything there. They've even helpfully hidden one of them, the travel insurance, below the fold, meaning that you've actually got to scroll to find it. Now, that might be a COVID thing, I don't know, but I think people are still possibly having travel insurance. Now, I want to be clear, and this is not just to protect my premiums. I actually love eSure. They've been really good for me, and I would recommend them to anyone. But their website has a problem, and it might be that they're trying to do this deliberate slowing down of attention to make the decision-making more rational. But given the competitivity of the UK insurance market, where we have meerkats helping us to search for best deals, I very much doubt that. Look at a couple of their competitors, and we can see how they've attempted to appeal to faster processing. Here is a company called the AA, in the UK, that's the Automobile Association, not Alcoholics Anonymous, and they've tried to use images. Now, we know from research that images can be like these can be understood in less than a second, about 500 milliseconds to get a real sense of an image and be able to describe it in a fairly significant amount of detail. And this can be further improved by using immediately recognizable items in those images, like the car. Objects are really good in images for helping people to recognize things and to understand what the image is about. Consequently, then, the dad and son image with the laptop for the home insurance, I think, is much less recognizable. It's also far more likely to pull attention because of those faces. Faces pull attention. So actually, a picture there of a house with a family sort of carrying boxes into it, for example, might have facilitated a much more rapid understanding of what that image is representing. And so people would locate the home insurance much quicker than the image that's on there at the moment. To me, that's not immediately clear. And again, they've completely given up on travel insurance. So I'm guessing this is a consistent thing. Direct Line have gone for speed with simple, easy to recognize line drawings. Now, they're stylized so that they all look similar, but they are distinct enough for you to be able to make a selection. So that's avoiding that issue that we have with similarity. The fact that they're simple line drawings makes them very fast for the brain to recognize. Images which have complex backgrounds and so on really slow down image recognition because the brain has to separate the objects from the background in the image. Something like this, you've done the job for the brain. It's actually a lot easier. Of course, all this relies on you being able to draw your attention away from the Ninja Turtle at the top, but that's clearly tied in with their advertising, so that's a whole other issue. But why is speed important on sites like these? Well, firstly, speed facilitates spontaneous decision-making. So as you saw with those two notes at the start, a fast decision, you will make it very quickly. And so you're actually more likely to click on something. Now, that might be the aim of many e-commerce sites. It's not necessarily the aim of an insurance site, but I suspect it probably is. Secondly, for services which have complex options, the leveraging of automaticity in being able to find where to go on the page actually relieves the burden of other cognitive processes, like working memory, because these heuristics actually bypass working memory. And this in turn means that the user will experience less stress, will experience less fatigue, and surely that's one of the objectives of any well-designed website. You've made it functionally easier for the user to do what they want to do. Now, I recently concluded a series of lectures and workshops on vision science, going through all of this kind of stuff in a lot more detail for Google. And I want to end today with this example from their maps design team. In the animation here, you can see two sets of color palettes. You can see one that has many subtly different shades, which was the old one. And then the new one, as it collapses down, has significantly fewer shades. They're more distinct, probably still too many. What I like about this is that they've understood that using color to convey information relies on the user being able to perceive the differences in the colors in the first place. Subtle hue and saturation shifts like these might be aesthetically pleasing, and we can have a conversation about how aesthetics ties in with all of this, because aesthetics is probably one of the biggest challenges for causing you to reject some of the ideas around attentional design. But accurately detecting each color in a map context would be a real challenge using that full palette for almost anybody, and especially for the 8% of males who have color vision deficiency. Some females have it too, by the way. It's not just a male thing, but it's majority males. By collapsing that range of colors, what they've done is they've simplified the design, but they've also enhanced the ability for the colors to communicate information implicitly. And by implicitly, I mean automatically, and therefore system one. They've also improve the accessibility of the website by doing that, because they've created more sort of light luminance changes between those colors, which makes it easier for somebody with color vision deficiency to detect the differences. So that's not a bad result, right? So I'm going to summarize and then we can get back to the questions. Vision is fast. It's really fast, and you only want to slow it down when you absolutely have to. Facilitating fast perception will improve your customer's experience, whether it's a website, a package design, an interface, or even instructions for how to use one of your products. Facilitating fast attention will decrease, oh, that was a bad one, will decrease search time, reduce fatigue, and increase the likelihood of selection, the likelihood of click-through, and the likelihood of engagement with a call to action. So hopefully from this brief foray into vision science, you can see that there's a lot to be gained from not assuming that everybody's perceiving the designs the way you do, especially if you're a designer. And by the way, there are a whole load of tricks that we can employ to influence perception in the same way that we can influence or manipulate attention. And the thing to remember is, as a designer, your understanding of the product or the website, your expectations of them are affecting your perception. You're really close to this thing when you're designing it. It's highly unlikely that a customer will look as long or closely at a design as you do. Anecdotally, I did a talk, one of these talks to a design company, and at the end of it, we were talking about package design, and one of the designers stuck their hand up and said, because I talked a lot about context and how that affects perception. One of the designers stuck their hand up and said, Tim, so are you suggesting we need to go out to the supermarket and see the products on the shelves to understand the context? And I'm like, yes, that's exactly what I'm suggesting. You need to get in the head of your user to understand how it might affect their perception, because they don't know everything that you do as a designer. So applying some of these ideas in the design phase will certainly reap benefits. And then using some of the research methods that we've talked about, the more implicit research methods like eye tracking, which can probe the unconscious responses of your customers in the testing phase, will deliver the proof that you have had the effects that you want. And that's all I'm going to spend my time on today. We can go into questions, but for those of you that have sat through the entire presentation on a Saturday morning, I thank you for your attention, whether it was fast or slow. And if I have turned you on a little bit to vision science, then I'm Dr. Tim Holmes on LinkedIn or Twitter. Please reach out to me, follow me. I tweet about this stuff all the time. And let's have some questions and a bit of a chat now. Manoj, over to you.
Yeah, wonderful, Tim. Very rich and intriguing content to play around with for designers and as well as those who are connected to, in some ways, visuals in their respective businesses. I'm sure there's a lot to chew. There's in the sequence of questions, there was a question which was outstanding, or I would say was there anyways in my head also. Spursh is asking the question that suppose we went with the slow decision making or slow design for a, let's say, an app or a construct or something.
Yep.
How does patterning play on that? Suppose once we see an ad or a design on one platform and we see a repetition of it in another platform, let's say in Instagram and other platform, Facebook later on. After a point, it will become a pattern. What you put a lot of thought for behavior shift or a slow decisioning or sorry, for seeing it slow, after a point it will be just a pattern. And you would probably be bypassing it. So how do you then play with the design to stand out? Which also happens in a way, the kind of over a period, certain ontologies in UX design starts becoming de facto.
Yep.
So what you imagine to be the focused activity, now it's become a de facto activity.
Yep.
How do you look at that?
Okay, well, this is a question that's come up a few times for me recently. Let me first of all, as I said, you sort of go through this sort of slow mechanism to train any behavior. So things like ads, for example, and appearing in particular locations. The brain is a pattern recognizing machine, and eventually the brain will start to say, okay, that ad, there's always an ad there. I'm not interested in ads. I want to see search results, or I want to look at content. So the brain will actually start to inhibit that location. It will actually effectively say that that's not part of the screen that it's even considering as a candidate for looking at for attention. Now, you can still disrupt attention in those situations, but you typically have to use some fairly, what I would call, blunt measures to do that. So this is where some of these more hard-hitting sort of salience-driven measures can be used to drive attention. There are also several mechanisms that you can use to direct attention to a particular location, to cue attention to a particular point on the screen. But as I say, these things become effectively hardwired, and so they can actually feel quite intrusive, quite invasive for a user if you start to try and push their attention to somewhere that they know they don't want it to go, somewhere that they have tried they've actually learned not to put it. So then you're down to well, how can I train their attention, or how can I maybe move this thing that they're now avoiding? Do I need to move it somewhere else? And one of the important things about training attention is, if you don't want a pattern to develop, then don't ever put a pattern in there in the first place, because the brain will spot it. So basically, from a design perspective, I've talked for a little bit in the past about Instagram. I think Instagram is kind of like the perfect ad delivery mechanism, because the way Instagram works, first of all, it's a nice visual interface. It's something that you're there to look at visual content. You're in a very browsy state when you're in Instagram, and so you're quite receptive to images whenever you start looking at it. And what's the first thing that happens in your Instagram feed? It's some content. It's the things that you actually went to Instagram for in the first place. You don't get an ad straight away. It's not like a pre-roll on YouTube. So at that point, you can see some of the content. And then you scroll, and because you're doing this probably on a mobile phone, the first ad was already off the screen when you first saw it, and then you scroll up and an ad comes in. Now you've already softened to Instagram by this point. You're kind of into, I'm looking at images. Those ads look awfully like the Instagram content that all the people you're following are putting on there. And so you can't spot it coming. It's camouflaged. You can't defend against it. It now takes over your entire screen. And so what else are you going to do? You're probably going to look at it at least for a couple of seconds whilst you're designed to scroll up. And so there's a potential for them to grab you at that point and to get that sticky attention going, hold your attention. And then they're super smart. And I always tell people to think that when you're thinking about behavior, you kind of need to think like you are a dolphin trainer at SeaWorld. Don't think of and that might be very insulting potentially to your customers, that you're treating them like animals, but you are conditioning behavior when you're doing things like this. And so the way Instagram actually works is that the rest of the ads sort of come intermittently after that point. There's always a bit more content to keep your engagement, to keep you there, and then there's some more content, and you can't predict when it's going to appear. And so it's very hard in that situation for the brain to develop a pattern, to recognize the pattern, and therefore to start to bring in an inhibition behavior that would stop you from looking at those ads. And that's what makes it so perfect. So the basic rules for behavior are, if you want to change a behavior that's already set in, is first of all, stop feeding the behavior by stop doing the thing that actually trained it in the first place. Secondly, you can potentially use methods to reorient attention, but sometimes they're going to be a bit clumsy. But if you are going to do that and you're going to try and retrain attention, then make sure you reward the user for having gone to the new location. Don't send them straight to something that's going to be the very thing that they've been trying to avoid in the first place. Send them to somewhere where there's actually going to be something interesting, useful, relevant to them, and then let them see the thing that you're trying to show them. Because that way, the reward behavior will actually help the conditioning. There's only two ways to condition behavior. It's reward or punishment. And in most cases, things like ads are perceived as punishment.
All right. There are more questions. We have probably few 5-6 minutes more, and maybe I can take one or two more questions. So Rahul is asking a question: are there any exercises to shift the handle from system 1 to system 2, and how do we practice that? In a sense, if we don't want the automatic decisioning always to take over, and we want to figure out influences and manipulations, or take a more rested decisions, are there any exercises which can develop this skill?
That's an awesome question. That's actually really difficult, because I mean, and you're effectively, well, first of all, you're trying to disrupt what the brain actually wants to do. So fortunately, I've done a bit of psychology as well as neuroscience, and I actually, when I went into psychology, I was thinking I was going to train as a clinical psychologist, and there's this. You probably have heard of cognitive behavioral therapy. This is actually an example of you trying to take things from system 1 back to system 2, and there's various mechanisms that they do there, but it's really hard to catch a system 1 behavior in the first place, so that you can start to retrain the brain, so you can start to challenge it. But certainly, I mean, all your classic sort of mindfulness techniques will help here, and certainly, I think those are the kind of things that you'd need to be thinking about. I don't know what the context is you're actually asking this question in, so it's hard for me to be more specific, I guess. But yes, by certainly paying, you can try and pay attention to what you're doing. I mean, one option would be to sort of, whenever you make any decision, is to try and count to 5 before you actually make the decision. So you give time for your brain to catch up. And I know people on YouTube promote that kind of thinking. So those kind of ideas will work, but they'll only work for probably for those 5% of those conscious decisions that you're making on a daily basis. The really hard part is to catch that other 95%, the ones that you are making instantaneously. Now, most of those are so automatic that they're things you want to do automatically, by the way. So that 10,000 decisions a day includes, like, when you're driving, all the decisions that you make when you're driving, and you actually want most of those to be automatic because you're too slow, if you're thinking about them, to respond to traffic conditions. Certainly on some of the British motorways, you'd be too slow to respond to that. But yeah, so yeah, try and actually put a circuit break in your thinking by trying to count to 5 before you make any decision that you think is important.
All right. So that was also the answer for another question which had come, similar question from Brett Home or Brett Home. How does one become truly non-judgmental, where one can see, hear, smell every stimulus impartially as if it was for the first time? I think probably you already gave some answers through mindfulness and thinking, taking a while. And I think in design thinking, we also use this user journey mapping tool and cognitive. Some of these CPT methods are also used in the design thinking for eliciting some of these automatic behaviors, decoding these automatic behaviors in the users. So,
but I would suggest you really don't. I mean, it's a lovely thought question about how you could see everything afresh for the first time, but I think you probably wouldn't want to. Babies scream for a reason, right? They're seeing that their brain's got to learn all this stuff in the first place, and so I really don't think if you went back to seeing everything from first principles, and certainly if you didn't have automatic processes based around the way the real world works, and like that illusion with those 2 gray panels that is based on just your understanding of physics and the way light works, if you didn't have those things actually working automatically for you, then I think you would probably never make it out of bed in the morning. You would just not be able to function. So they are really important. It's just trying to understand how sometimes they can be interfering with maybe what would be better for you or what you actually like, as opposed to what you're feeling sort of compelled to do.
just this on this note, Tim, how do we see impartially as if for the first time? I'm just reminded the poster behind me says a poem by Emerson, and it reads like, one should not cease from exploration. At the end of all our exploring will be to arrive where we started and know the place for the first time. A rather poetic tweak to it. And I think we are already running 1:30, which is about amazing conversation, very rich content. I'm sure a lot of us will benefit from it. Thank you so much for being with Dive and with Turin Labs. Thank you, Tim.
Thank you. Thank you for having me.
Thank you, everyone who joined on this afternoon. Thank you so much.